section A5 right here, some rational stuff. This can be a very difficult section. Have some patience. You may have to watch the later part of this video one time or another. Very important section. Just take a deep breath. I should be back soon. But if you take these videos serious, you should be okay. So what we're going to do, section A5 is all about rationals. We're going to simplify, we're going to multiply, we're going to divide, we're going to add rational expressions. Fractions. They call fractions in arithmetic add and subtract, multiply, and divide fractions. Well, we're going to add, multiply, divide, and add fractional algebraic fractions. Algebraic fractions right here. So here's one right here. Let's simplify this guy right here. Simplify. Rectify the simplification right here. So I have x squared plus 4x minus 5 divided by x squared minus 2x plus 1. So we're going to see if that thing simplifies. See if it's an improper fraction. See if there's a factor or like factors on top and bottom. Well, the only way to find out if the top and bottom share like factors, we're going to factor the top. We're going to factor the bottom. That's why the last section on factoring was very important. Hey, let's factor this guy right here. We can do AC and we do AC and we know that A is 1 and we know that A, oh, two numbers multiplied together come down to 5 to add up to 4. Yeah, we got them right there. It is. We got positive 5 and negative 1. Negative 1 times positive 5 is negative 5. Negative 1 plus 5 is 4x. That's factorization. Hey, let's factor x squared minus 2x plus 1. Slow down. No, just pause the video. Two things multiplied together equal 1. They add up negative 2. Hey, how about negative 1? Negative 1, negative 1, x minus 1, x minus 1. And so now we have this fraction is the same as this guy right here, only the factor form. The x minus 1's cancel. What do I have? X plus 1, pardon me. Whoa, slow your roll there, Lucy. X plus 5 over x minus 1. That's this guy simplified form. This thing has no more like factors. No more like factors. Please don't cancel the x's, please. That's a very common Algebra 1 error. Please do not do that. Let's go to the next slide right there. Hey, multiply, multiply. Hey, you learned, and I'm sorry that you did, but in elementary school you learned to multiply fractions. You multiply the top, multiply the bottom. Stop. That's not how you do it. Sorry. What you're going to do is you're going to factor everything. And before you multiply, you're going to cancel like factors. Factor everything and then cancel like factors all over the place. And this is not called cross multiplication. You might call it cross canceling if you wanted. What it's called is factoring and then cross off the like factors top and bottom. Let's see. I got 12 divided by 35 times 15 divided by 16. Hey, what's factorization of 12? 12 is 3 times 4. Hey, what's the factorization of 15? 3 times 5. What's factorization of 35? 5 times 7. Why are you starting out with easy stuff so that you can understand the more difficult algebraic stuff? And I'm going to do this a couple times. Each time before I go into an algebraic problem, I'm going to do a simple arithmetic problem. Something with numbers and no variables to help you out here right there. 16 is 4 times 4. Now I have 3 times 4 over 5 times 7 times 3 times 5 over 4 times 4. These guys here, I have little factor trees if you want to go, you can do little factor trees. And now we're simply going to cancel like factors. Do I have a 3 on the bottom? No, I don't. Do I have a 4 on the bottom? Oh, right there. So I can cancel those 4s. Bam, bam. And those become 1s when you cancel them. Bam, bam. Do I have a, no, I don't have any 3s. Leave the 3s alone. Hey, about a 5. Do I have a 5 on the bottom? Oh, right there. So this 5 and this 5 cancels. And so now what do I have left on top? I have 3 times 1 times 3 times 1. 3 times 3 is 9. I have 1 times 7 times 1 times 4. 7 times 4 is 28. 9 over 28. And if you do this way, if you factor and then cancel the like factors, the product will become simplified. Now, could you multiply 12 times 15, 35 times? Yes, you could. And then you do some factorization of that and simplify it to 9/28. You could do that, and that's how you were taught. I'm sorry that you were. But if you look at this rascal right here, this next algebraic guy, whoa, what's going on here? I got a little ahead of myself. But if you look at this dude right here, oh my goodness gracious. you can't multiply the top. So now I have another algebraic fraction times an algebraic fraction. Let me cover this up so we can look ahead here a little bit and go, ooh, ooh. Raise it up so it's easier to see. Now I got x squared minus 3x minus 10 divided by x squared plus 2x minus 35 times this nasty thing, x squared plus 4x minus 21 over x squared plus 9x plus 14. Am I going to multiply this trinomial times this trinomial and this trinomial? No, I'm not going to do that. What I'm going to do, now I need to employ my factoring skills that I did in the last section. I'm going to factor all those guys and see if we have any like factors to cancel. Okay, so let's factor this dude right here. Two things that multiply together, negative 10, to add up to negative 3. Negative 5 and 2. Right there, x minus 5, x plus 2. Hey, two things that multiply together, negative 35, to add up to 2. Yes, you got it. Negative 5 and 7. Adds up to 2. Negative 5 times 7 is negative 35. Same thing here. Two things multiply together, negative 21, to add up to 4. 7 and negative 3. Bam. Positive 7 and negative 3. How about x squared plus 9x plus 14. Two things multiply together are 14 to add up to 9. Easy, 7 and 2, both positive. So this is what I have. Here's my little factor trees, if you will. Raise it up there a little bit. Here's my little factor trees. This guy here becomes this. This guy here becomes that. And now I cancel like factors. Cancel like factor. Let's cancel some like factors here, okay? So now, do I have an x minus 5? Oh, yeah, on the bottom right there. So this whole thing here, those things cancel. Keep in mind, you can pause the video and rewind if you need to. Okay, Earl? Do I have a factor of x plus 2? No, right there it is. Okay, so I can cancel that guy and that girl. Well, they're both guys because it's the same thing. That's why I can cancel them. How about an x plus 7? Oh, right there. I can just cancel the one right below it. Do I have an x minus 3? No, I don't. All I have left is an x plus 7. All I have left here is an x minus 3. So, hey, that comes out pretty easy. Pretty easy. Don't be intimidated by it. It's not that difficult. So the product of this nasty multiplication problem is simply x minus 3 over x plus 7. Not too bad. Not too bad if you factor and cancel. Hey, how about adding some fractions? I think we're going to add or subtract. You need common denominators. Oh, holy moly, rock and rolly. Common denominator. Oh, I can do this. Yes, you can. This is arithmetic. This is a 5th grade, 6th grade, 4th grade. I don't know when you do it. But we're going to do this example first. 3 over 10 plus 5 over 12. I need common denominators. So what I need to do is find the least common multiple, of 10 and 12. And I'm probably going to show you a new way to find the least common multiple. A lot of times, people just list the multiples. Well, that's okay if you're doing numbers, not okay if you're doing algebraic expressions. So let's find the least common multiple of 10 and 12. How do you do that? Well, you take 10 and you do the prime factorization of 10. You've done that. Factor 2 times 5 is 10. They're both prime. Find the prime. Ho, text, put that phone away. Put it away. Please pay attention. This is difficult. Oh, I can do this. I know you can do this, but maybe not the next problem. So please follow along, will you? Put it away. Here we go. Prime factorization of 12. 2 times 2. 2 squared times 3. Okay? And so now the least common multiple of 10 and 12 is the product of all of the separate factors that you see. I see a 2, I see a 3, and I see a 5. The product of the separate factors to the highest power that you see them. Well, the highest power that I see a 2 is 2 squared. The highest power of is 1. The highest power of 5 is 5. So this is the least common multiple. 2 squared times 3 times 5. Which just so happens 4 times 3 is 12 times 5 is 60. It is 60. Let's write it. But we're not going to write it 60 just yet. There's a reason for this. There's a reason for this madness, if you will, and you're going to find out in the next example. So here's one I have. I have 3 over 2 times 5, which is 3/10. 5 over 2 squared times 3, which is 5 over 12. And I'm going to add them together. Well, here's the least common multiple. The common denominator. The least common multiple of 10 and 12 is 60, or 2 squared times 3 times 5, right there. And so now this is going to be the common denominator, and I'm going to ask myself a question. What does this dude here have that this guy doesn't? Well, that guy needs looks like it needs a 3, and it needs another 2, i.e. it needs a 6, 2 times 3. So I'm going to multiply this guy by 1 in the form of 6 over 6. Because 2 times 6 is 12, times 5 is 60, that's 60. And then 3 times 6 is 18. And now I ask myself another question. What does this guy have that this guy doesn't? A 5. Easy enough. So I multiply this fraction by 1 in the form of 5 over 5. 5 times 5 is 25. I have my 60. And so now I have the common denominator, which is 60. 18 plus 25 is 43. Easy enough. Oh, Mr. Struffel, this is an advanced math class we're doing. Yes, we are. We're doing that because, ladies and gentlemen, how about this rascal right here? Oh, it's a little bit different, isn't it? And we will encounter problems like that this year and next year. So I have x over x squared minus 7x plus 6. Minus, it doesn't matter if you're adding and subtracting, you still need least common multiple. You still need a common denominator. So I have this guy right here, x over x squared minus 2x minus 24. And I'm going to subtract. But I need to find the least common multiple of this guy and this guy. How do you find the least common multiple? How do you find that? You factor them. You factor them, and that's what we're doing over here. Okay. I have x squared minus 7x plus 6. Two things multiplied together equals 6. They add up to -7, -6, and -1. Factorization of this. X squared minus 2x minus 24. Two things multiplied together, -24. They add up to -6. -2, sorry. Got a little ahead of himself, sorry. -6, +4. That's the factorization. So the least common multiple is the product of all the separate factors. The highest power that you see them. Woo. They're all to the first power. So what are the separate factors? The separate factors are x minus 6, x minus 1, and x plus 4. So this is the least common multiple of these two guys. It's going to be the common denominator I'm going to use to subtract those fractions. So let's go back here, and this is what I'm going to do here. Okay? So this is what I have. I have this guy minus this guy, and this is my common denominator. So I'm going to ask myself a question. What does this guy have that this guy doesn't? Think about that a moment. I'm going to scoot it over here. And keep in mind, you can, at this point, I would pause the video and think about what's going on. Because you want to know, what does this guy have that this guy doesn't? What does this guy have that this guy doesn't? Pause the video. Okay, now that you pause, I'm back. Well, this guy here, this x minus 6, x minus 1, looks like I need an x plus 4. Oh, so I'm going to multiply this fraction by x plus 4 over x plus 4. What does this guy have? Well, this guy here is x minus 6, x plus 4. Looks like I need an x minus 1, so I'm going to multiply this by x minus 1 over x minus 1. And I do that in the next slide. Here we go. Here we go right here. Here's my x plus 4 over x plus 4. This is 1. I'm not going to multiply out the bottom. I don't have to. That'd be ridiculous. I'm going to leave the bottom like this, but I am going to multiply x times x plus 4, which is going to be x squared plus 4x. Okay, and I found out that this guy needed an x minus 1 to meet this denominator, so I'll multiply this whole thing by x minus 1 over x minus 1. X times x minus 1 is x squared minus x. Leave this guy alone. You don't have to simplify that. Do not multiply those three binomials out. Do not do it. Leave the denominator factored. So, don't forget this guy. So now this is my common denominator. Right here, I'm going to leave it go, and now I'm going to Well, I'm going to subtract this guy from that. So I have x squared minus x squared. The x squares are gone. I have 4x minus negative x. 4x minus negative is 4x plus x is 5x, and this is that sum, or difference, if you will, of those two fractions that I started out with. Okay? It's going to get a little bit froggy right there. One more thing we're going to go over in A5. Simplifying complex rationals. Oh, my goodness gracious. This is going to be very prevalent next year in calculus, and prevalent this year also. So I have 2/3 plus 3/5 divided by 1/2 plus 4/5. And I guarantee you, give it a whirl. Give it a whirl without any instruction right there. Give it a whirl. I'll step out of the screen. Give it a whirl. Give it a whirl. Give it a whirl. I know what you're doing. I know what you're doing. What are you doing? What are you doing? Hey, let's listen to some, yeah. What happened? Don't do that. Don't do what you're doing. I know what you're doing is you're adding these fractions, you're adding these fractions, and then you're going to flip, multiply. No, do not do that. What I want you to do, and this is so much easier to do this, is what I want you to do is find the separate factors, the separate denominators. Circle all the separate denominators, not the big one. Circle. Well, I've got a separate denominator. A separate denominator. This great big thing is a great big. Don't circle that. Circle the separate denominators. And those are my separate little itty bitty. Circle the little itty bitty denominators. You're not going to believe how easy this is. You certainly will not. So now I have 3, 5, 2, and 5. So I want to find the least common multiple of 2, 3, and 5. Well, they're all prime, so the least common multiple is going to be 30. 2 times 3 times 5. And so what I'm going to do here, I do. What I'm going to do then, I found that 30. Bam. I'm going to multiply this guy by 30 over 30. Well, specifically 30 over 1 divided by 30 over 1. That's a great big 1, because the property of algebra is that I can multiply anything by 1 and not change its value. And that's exactly what I'm going to do here. It's going to make this so sweet easy. So I'm going to multiply this guy right here times that guy times that, use the distributive property, that times that, and that times that. Well, 30, as we know, is 2 times 3 times 5. If I have 2 times 3 times 5 times 2 over 3, these 3's cancel. So I simply have 2 times 2, which is 4 times 5 is 20. Pause the video. Okay, I'm back. Now I have 2 times 3 times 5 times 3 over 5. These 5's cancel. So I have 3 times 2 times 3, or 6 times 3 is 18. Thing on the bottom right there. I have 2 times 3 times 5 times 1/2. The 2's cancel. I simply have 3 times 5, which is 15. 2 times 3 times 5 times 4 over 5. These 5's cancel. And then 4 times 2 times 8 times 3 is 24. So what do I have? 38 over 39. And I guarantee you, ladies and gentlemen, it's a lot quicker, even if you're doing just numbers. That's the way to do that, because now you're going to be, yeah, that's a rascal. That's an expression that's going to come up, an expression like that is going to come up very often in calculus. We need to know how to simplify these complex rational things. And so what I'm going to do is circle the little denominators. Don't worry about the big denominators, circle the little ones. Keep in mind you can pause, you got to pause. Think. Circle the separate denominators. Here we go. There's only 2 here, x and x plus 1. Separate denominator, 1 there, don't count. Separate little 1, don't circle that. That's not a separate denominator. That's a separate numerator. Okay? So I have x and x plus 1. So my least common multiple is simply going to be x times x plus 1 right there. Okay? X times x plus 1. Sorry about the noise. The bell. You know, that doesn't signal the end of class. You know, this is, I think today is July 7th. You're watching this probably about August something. I don't know, August I don't know what the date is, doesn't matter. So I'm going to multiply the top and the bottom by x plus 1, x times x plus 1 over x times x plus 1. Here we go. You have to be very careful, very meticulous in doing this. Okay? So let's see. I think I have the video on that. I do. Another slide, sorry. So I have x over x plus 1 times 3. Well, nothing cancels. So I simply have 3 times x plus 1. That's what this particular term is. That guy times that. Now I'm multiplying this guy times this. Well, these x's cancel. So what do I have left? What I have left is x minus 1 times x plus 1. Just write it out there like that. Now I have this guy times 4, which is simply 4 times x plus 1, plus this guy times this guy. These x plus 1's cancel because they're factors. All I have left is x squared. X times x. So this is what I have. Now I'll simplify this. I'm going to multiply through here. The 3x times x is 3x squared. 3x times 1 is 3x. This guy multiplied together, x minus 1 times x plus 1. Yes, x squared minus 1. Okay, difference of squares. 4x times x is 4x squared. 4x times 1, 4x. Plus x squared. 4x squared plus x squared is 5x squared. I just have a 4x. I have a 3x squared plus an x squared is 4x squared. I still have a 3x and minus 1, and bingo, bam, that's the simplified version of this nasty, complex things here. Okay? So there you have it. A few examples, ladies and gentlemen, boys and girls, friends and neighbors, for problems from A.5. Should be back maybe by the end of this week, maybe not. Hopefully by the first of next week. Catch you guys later.